Hi, I'm Sean Harris with Positive Energy, and I do building performance testing. I do code testing, I do HERS testing, we do energy audits, and general building performance. Today we're going to talk about a few tests that I do on a regular basis throughout those different tests. We'll test the building envelope, we'll test the ducts, we'll test airflows, and how all of this relates to energy efficiency, comfort, and the overall health of the home. So when I arrive at a house, a couple of things I look for. First, when I pull up, I look at the orientation, look at how the house is oriented, how the shading is. This particular house has a big shade tree in the front here. I look at windows. Windows are obviously a big source of infiltration. These windows in particular are single pane, and they're the original windows to this house that are also very leaky. So we look at those types of things to make sure that there isn't anything that we can do to sort of cut down on that infiltration. So infiltration is challenging in houses because the more air that gets in from the outside, the less comfortable you're going to be, and the more energy you're going to have to use to make that house comfortable. So in this house, you've got pier and beam construction, which oftentimes means that there's going to be more infiltration through the floor. You've also got the windows, as I mentioned, and there are other penetrations throughout the house, roof penetrations, wall penetrations, that can lead to air infiltration. So one of the things you can do to cut down on infiltration is to spray foam inside the crawl space. And that's what they've done here up on the, basically the underside of the flooring. They've installed spray foam so that there's less infiltration. After looking around the outside of the house and inspecting it for possible penetrations and looking at the orientation, I'm then going to go inside and I'm going to inspect the inside and also set up for a blower door test so we can actually measure the infiltration. So before I set up for a blower door, I walk around the inside of the house and I inspect things like the windows again, other penetrations, and one of the most commonly missed items is the weather stripping around the doors. And these things can be installed, but if not installed properly, you're not going to get a good seal on the door, and therefore air can just come in as it pleases, and that's not a good thing. So I look at this strip and how this makes contact with the door. So light cans are another source of infiltration. If not sealed properly behind, this can cause a lot of air to move back and forth between the cold attic and the warm house, or in the summer, the cold house and the hot attic. All right, so now we're set up with the blower door. And the first thing I'm going to do is run a baseline. Wait, let's cut that part out. First, I walk around the house and I set all the doors open and I turn off the air conditioner, make sure that everything is sealed, all the windows are sealed, so that I'm ready to do this blower door test. Then I run a baseline by turning on the manometer and measuring the difference in pressure outside to inside. So I'm baselining to sort of incorporate the wind and other changes of pressure outside that happen. After running the baseline, I am ready to start the test. So I'm depressurizing the house to -50 pascals. Pascal is a very small amount of pressure, a fraction of a PSI, and what it's going to do is it's going to simulate 20-mile-an-hour winds on all sides of the house. So if your windows are leaky, you can actually go up to them and feel the leaks coming out, and that would be the leakage, the air that you would feel if there was a 20-mile-an-hour wind hitting that wall directly. Alright, so we've now reached 50 pascals, and this house has roughly 1980 CFM of leakage, which isn't too bad. Now I'm going to walk around the house and I'm going to feel for leaks to see where some possible leakage might be. So we have our blower door running, depressurizing the house, which means that I can feel air coming in through windows and other penetrations in the building envelope. And this particular window, they have painted shut the seam in between these two windows to stop the air from coming in. But even after doing that, there's still leakage around here and leakage at the bottom that is still coming in, and that would be a good place for them to caulk and seal up the windows. So we do blower door tests not just to measure the leakage that we can see at common places like can lights and windows and doors. We do it to measure the leakage that we can't see. So the blower door measures CFM of airflow. That's cubic feet per minute of air coming into or going out of the house at this test pressure that we measure at. And CFM at 50 can be changed into a number called an ACH 50 number, which is the air changes per hour at 50 pascal test pressure that we test at. And that means that what we want to know is how much air goes between the inside of the house and the outside of the house. So how long would it take for the volume of air that's inside the house right now to change with the outside air?